In 2006, federal agents in San Diego discovered a tunnel running from a warehouse near the Tijuana airport across the border and into another warehouse in California. It was 730 meters long. That's roughly 8 full-size football fields laid end-to-end, underground. The floor was reinforced concrete, the walls were lined. There was a ventilation system to keep fresh air moving through the entire length of it. There was lighting, and it ran nearly 30 meters below the surface, so deep that most detection technology at the time couldn't reach it. When agents entered it for the first time, they found 2 tons of cannabis inside.
That wasn't the first tunnel, and it was nowhere near the last. Between 1990 and today, authorities have discovered more than 200 illicit cross-border tunnels beneath the US-Mexico border. Some are crude holes, barely wide enough to crawl through, but some are something else entirely. They are engineering projects, sophisticated, planned, deliberately constructed underground infrastructure built by organizations with the money, the workforce, and the patience to build something of this nature. This is what those tunnels actually are, how they are built, how they are found, and why, despite everything, they keep getting built. To understand what we're talking about, you need to step back and look at the numbers. Since 1990, US Border Patrol and partner agencies have discovered over 200 illicit tunnels along the southwest border with Mexico. The vast majority of them, concentrated in 2 specific areas, Otay Mesa in San Diego County, California, and the Nogales area of Arizona. These aren't spread evenly across the entire 3,000-kilometre border. They cluster, and there is a reason for that. Soil. The ground in these specific areas has a particular clay-rich composition that holds its shape when excavated. It doesn't collapse easily. It doesn't flood easily. For anyone trying to dig a tunnel and keep it standing for months or years of active use, it is ideal. The cartels didn't pick these locations randomly. They picked them because engineers told them to. The tunnels themselves fall broadly into 3 categories. The first is what Border Patrol officially calls rudimentary tunnels, or, less formally, gopher holes. Short, narrow, sometimes just a few meters long, hand-dug, used to move small quantities or people quickly. They collapse, they flood, they are found. They are not what this documentary is about. The second category exploits existing infrastructure: storm drains, sewer lines, maintenance passages. An existing tunnel or channel is accessed, modified, and extended. Useful, but limited. And then there is the third category, what authorities call sophisticated tunnels. And sophisticated is, if anything, an understatement. These tunnels can stretch for hundreds of meters, sometimes over a kilometre. They run 15 to 30 meters below the surface, sometimes deeper. They are equipped with electrical systems, ventilation systems, water drainage pumps, lighting, and in the most advanced cases, rail systems. Narrow gauge tracks running the full length of the tunnel, with motorised carts used to move hundreds of kilograms of cargo at a time, efficiently and quickly. The longest tunnel ever discovered along the southwest border was found in August 2019 in Otay Mesa. It ran for 1.3 kilometres, more than 400 metres longer than the previous record holder. It was equipped with a rail system, ventilation, electricity, and high-voltage electrical cables. Authorities believe it had been operational at some point before they found it. When they entered, they found sandbags blocking what they believe was the former US exit. No drugs, no people, just the tunnel, just the engineering. The question that most people never ask is the most interesting one. Not who built it, but how. Building a sophisticated narco tunnel is not a weekend project. It is a construction operation, planned, engineered, and executed over months, sometimes years. And it begins, like any construction project, with a problem you have to solve before you dig a single shovelful of dirt. Where does the earth go? A tunnel 700 metres long and roughly 1.2 metres wide by 1.5 metres tall displaces thousands of tonnes of excavated material. You can't leave it in the tunnel. You can't pile it outside the entrance without someone noticing. Every tonne of soil that comes out of the ground has to go somewhere, transported, concealed, disposed of in a way that doesn't alert anyone. The solution, in documented cases, has been to disguise the operation as legitimate construction or industrial activity, a warehouse, a factory, a business that has trucks coming and going. The excavated material loaded discreetly and moved, mixed with legitimate waste, taken to landfill sites, spread across multiple locations. It is not a small logistical challenge. It requires planning that begins long before the first shovel enters the ground. The entry and exit points are equally deliberate. In almost every sophisticated tunnel discovered along the California border, the US entrance has been located inside a commercial or industrial warehouse, not a residential property. A warehouse in an industrial park, the kind of building where trucks come and go at all hours without anyone raising an eyebrow. The entrance itself is typically a shaft dropping vertically from the warehouse floor, concealed beneath trapdoors, heavy machinery, dumpsters, pallets of goods. In one documented case, discovered in 2016, the entrance was hidden beneath a commercial trash bin that was also used as a container for the drugs moving through it. A forklift would place the bin directly above the shaft, and the drugs were loaded straight up into it from below. Then there is the engineering of the tunnel itself. Digging horizontally underground over hundreds of meters requires dealing with a set of problems that any legitimate mining or tunneling engineer would recognize immediately. The first is structural support. Without shoring, the installation of supports along the walls and ceiling of the tunnel as you excavate, the ground will collapse. In the most sophisticated tunnels, this shoring is professional grade. Timber frames, concrete reinforcement, steel supports. The floor is often poured concrete. The walls are lined. The ceiling is braced. These are not improvised solutions. They are construction techniques. The second problem is ventilation. A tunnel that length, with workers excavating at the far end, accumulates dangerous concentrations of carbon dioxide and dust. Fresh air has to be continuously pushed in and stale air continuously pulled out. The ventilation systems documented in the most sophisticated tunnels have included ducted fan systems, the kind used in legitimate mining operations, running the full length of the tunnel. Without them, workers at the excavation face could not survive. The third problem is water. Below the surface in these areas, groundwater intrusion is a real and constant threat. A tunnel that floods is a tunnel that collapses. The sophisticated tunnels have addressed this with electric water drainage pumps, running continuously to keep the tunnel dry. When agents enter a tunnel and find a working drainage system, it tells them two things. The tunnel was built by people who understood the engineering, and it was designed to be used for a long time. And then there is the rail system. In the most advanced tunnels discovered, including the record-holding tunnel found in 2019 and several others in the Otay Mesa area, narrow-gauge rail tracks run the full length of the tunnel. Motorised carts, small enough to fit within the tunnel's dimensions, but large enough to carry hundreds of kilograms of cargo, move along these tracks. It transforms what would otherwise be a slow, labour-intensive process of moving goods by hand through a narrow passage into something far more efficient. A load that would take hours to carry through manually can be moved in minutes. The construction of a tunnel like this, according to experts who have studied these operations, requires a team of skilled workers, a supply chain for materials, a logistics operation to remove excavated soil, months of construction time, and a significant financial investment. The Sinaloa cartel, which US authorities have linked to the majority of sophisticated tunnels discovered in the San Diego area, has been described as having the resources and the organisational capacity to treat tunnel construction as a long-term infrastructure investment. Build it once, use it many times. Move enough product through it before it's found to make the entire operation profitable. The United States government is not unaware of this, and the response to the tunnel problem has been, over the past 2 decades, a significant and ongoing investment in detection technology. The challenge is considerable. A tunnel running 30 metres below the surface in dense, clay-rich soil is genuinely difficult to detect from above. The most promising technology is ground-penetrating radar, electromagnetic waves fired into the ground that construct an image of what is below. But ground-penetrating radar has a documented limitation. According to researchers working on tunnel detection for the Department of Homeland Security, standard ground-penetrating radar performs poorly at depths beyond about 12 metres. Given that the most sophisticated tunnels run at 20, 25, 30 metres or more below the surface, standard radar simply doesn't reach them. Lower frequency radar can penetrate deeper, but lower frequency means lower resolution. The image it produces is less precise, harder to interpret, more prone to false readings from natural underground features like rock formations or water pockets. Researchers have been working on this problem for years. As of the time this documentary was made, they have not fully solved it. Seismic sensors offer a different approach. Underground construction creates vibrations, the sound of digging, drilling, jackhammering, that travel through the ground as seismic waves. Sensitive geophones buried near the border can detect these vibrations, but the border area is not quiet. Road traffic, industrial activity, construction, all of it creates seismic noise that has to be filtered out before the signal of a tunnel being dug can be identified. It is a technically challenging problem, and one that researchers are still actively working to solve. Robotic systems have also been deployed, small vehicles equipped with cameras and sensors that can be sent into a tunnel once it has been partially identified, to map it and gather intelligence without putting agents at risk. But a robot can only go into a tunnel that has already been found. Ed Turner, a project manager with the US Department of Homeland Security's Science and Technology Directorate, made a statement that has stayed with researchers in this field. He said, and this was the honest assessment of someone working at the center of the detection effort, as of that time, not a single sophisticated tunnel had been found by technology. Every one of them had been found by law enforcement work or by chance. Tips from the public. An observant agent who noticed something that didn't add up. A neighbor who heard unusual sounds. The smell of fresh soil. Trucks coming and going at unusual hours from a building that should have been quiet. According to US Border Patrol, the most reliable detection method remains what they call good old-fashioned police work. Following leads, watching locations, waiting. And while authorities watch and wait, the tunnels keep being built. According to documented statistics, tunnel construction increased by 80% between 2008 and 2012 alone. The more the above-ground border was reinforced with fencing,
cameras, sensors, and agents, the more the organizations responsible for moving drugs went underground. The wall doesn't stop a tunnel, it just makes the tunnel more valuable. Since 1993, more than 95 tunnels have been discovered and decommissioned in the San Diego sector alone. 95 tunnels in one sector over 3 decades. Each one found, each one filled, each one replaced. Right now, at this moment, there are tunnels beneath the US-Mexico border that have not been found. That is not speculation. That is the documented assessment of the people whose job it is to find them. Border Patrol has defined only 15% of the southwest border as strongly secured. The underground is a different problem entirely, one that technology has not yet solved and human intelligence alone cannot fully cover. Thank you for watching this one through. If you're the kind of person who likes knowing what's really going on beneath the surface, subscribe. There is a lot more where this came from.